Super Heavy tests almost all of its Raptors. The worst case scenario for space debris actually happened. A kilonova is coming and a new map of all the matter and dark matter in the universe. All this and more in this week's episode of Space Bites. We almost got a full static fire test of all of the Raptor engines on the Super Heavy booster. So on Thursday, we got a test from SpaceX. Their hope was to test all 33 Raptor engines on Super Heavy booster number 7. And we got the test, and you couldn't really tell. Like, it was just like a whole lot of steam and fire, and we've got to assume that rockets were tested inside of that. And we got an announcement after the fact that only 31 of the engines were successfully tested. According to Elon Musk, one was shut down before the test and another one shut down automatically during the test. But according to Elon Musk, with just 31 engines, that's still enough thrust to kick Starship into orbit. So I guess this meets their requirements. We got an announcement from Gwen Chotwell that the Super Heavy and Starship are going to be attempting an orbital launch probably in March, maybe even as early as March 1st. So at this point now, we're probably just a few weeks away from seeing an orbital attempt of this fully reusable 2-stage rocket. I can't wait to see this. I'll keep you posted. 2 weeks ago, I mentioned that the worst case scenario in space debris almost happened when a spent booster and a Russian satellite came within about 6 meters of each other, and if they had collided, they would have thrown tons and tons of debris into a very high altitude, above 1,000 kilometers. And what that means is that the debris would have lasted for decades, beyond the end of the century. And this would contribute to increasing amounts of space debris. Little did I realize that a version of that worst case scenario had already happened back in early January. So we got this tweet from Space Force saying that they were tracking a Russian Cosmos 2499 satellite and detected that it broke up in orbit. And it was even a little higher. It was an altitude of 1,169 kilometers, and they detected that it broke up into 85 separate pieces that are now in orbit. And this is worse than the scenario that I mentioned before, because the altitude is higher, and the altitude is everything, because that defines how long this stuff stays in orbit and pollutes the orbit. Stuff that's in low Earth orbit, stuff that's, say, 500 kilometers in altitude, it reorbits within about 5 years. The stuff that is above 1,000 kilometers, it's going to last for decades, if not centuries in some cases. So this is not great. So this isn't the first time that this has happened, that one of these satellites has broken up. In fact, this isn't the first time this has happened for this specific satellite. About a year ago, it broke up into another 20 plus pieces. And we've seen another version of this satellite break up several years ago into multiple pieces. And what's going on? Now, people believe that these are some kind of prototype Russian satellite that's designed to change orbit, maybe do docking maneuvers, various other behaviors. We're not really entirely sure what it's doing. And so people are theorizing that there's some kind of design flaw in these satellites that's causing them to break up prematurely into all of these different pieces. Whatever the case, it's not good, and it's going to pollute the space environment for a long time into the future. Hopefully this is the last time this happens, but with the number of times we've seen this, I'm sure we're going to see this happen again. Now, how can we fix this problem? It's been estimated that unless we clean up 5 big pieces of space junk every year from these high altitudes, the problem is just going to get worse and worse. Like, that is the rate that we need to remove debris so that we're not making the space environment more and more polluted. So what would it take to be able to remove all of this junk? Now, the first thing is obviously put some kind of retro rocket on your spacecraft so that when it's reached the end of its life, it can fire its thrusters, lower its altitude, and burn up in the atmosphere. But what about the stuff that is already up there? Now, we talked about the drag sail test, where you launch this tiny solar sail that inflates and increases the drag of the satellite and causes it to deorbit much more rapidly than before. And what about the ones that don't have this drag sail on board? Well, we've got to do something else. A lot of people think, like, why don't you just send up a spacecraft to collect the space debris and then bring it back down to Earth? But the problem is that each one of these satellites is on its own trajectory. And so in order to be able to match up with it and to grab it, you have to mirror its trajectory, which means you need to have a whole bunch of propellant. You need to be able to catch up with it and be able to deorbit it. So pretty much you're going to need to send one spacecraft per piece of debris. Now, you maybe could catch a couple if you've got enough propellant on board and the delta V is within your parameters. You could catch multiple objects, but pretty much you're going to need to spend hundreds of millions of dollars per piece of space debris to bring it back down to Earth. The most effective solution that I've seen is some kind of system that can affect multiple targets over the course of a long mission. One example is you launch an orbital laser, and what it does is it just waits as space debris flies nearby. It fires the laser at the space debris, ablates a little bit of its material that acts like a little thruster on the rocket. So each time it flies by, it gets a little bit more of a thrust and slowly lowers its orbit until eventually they deorbit. But there's another idea that I really like, and it's called an ion beam shepherding system. And this is an idea that's been kicking around for about a decade. There's a big investigation from the European Space Agency into this technology. And essentially you take the ion thruster on board a spacecraft and you fire it at a target. So it is the thrust of the spacecraft, but you can also fire it as a cohesive beam at some piece of space debris. The ions coming out of the thruster impact the piece of space debris and lower its orbit until you're able to deorbit it. And so a new paper just came out from a team of Russian scientists that they propose that you can use multiple thrusters on board your spacecraft to do an even better job. Now you have multiple ion thrusters on the spacecraft. They are able to sort of combine their forces on the target, but you can do even more things. You can fire them in different ways. So you can rotate targets, maybe put them into a bigger cross section for impacting the atmosphere of the Earth. So it's a pretty clever idea. And I really like this idea of ion beam shepherding. And I wouldn't be surprised if we see a test coming of something like this in the coming years as a way to effectively bring down space debris. But the bottom line is, we need something. We need some way to be able to bring this debris back to Earth. Google's new AI got its James Webb facts wrong. I'm sure you've probably seen that there's this new arms race in artificial intelligence. ChatGPT by OpenAI has been funded by Microsoft, and people have been really enjoying it. It's pretty fun, and it's gained one of the largest followings ever seen for a new service like this. And people have said this is a crisis for Google, because why search for a recipe on Google and then you get this page that's got a bunch of ads on it, and then you go through this big long story about the person's life and childhood until you finally get to the recipe down at the very bottom. So to maximize the ads and for the SEO, if you go to ChatGPT and you ask it for a recipe, it just provides it and instructions, and you can just make the food. They did a test in Paris on Wednesday, and I tried to go and watch the video after the stream, and it was private and I couldn't find it. And it turns out that they had made an error in their presentation about new discoveries made by the James Webb Space Telescope. They asked it what kinds of interesting things you could tell a 9-year-old about the discoveries made by JWST. A bunch of them were correct, but in the end it said that JWST was the first telescope to take a direct picture of an exoplanet. And that's not true. And a bunch of astronomers caught the error and let Google know. And in fact, the first image of an exoplanet was taken way back in 2004 by the Very Large Telescope. If you watch Space Bites on a regular basis, and I know you do, then that piece of news would have come as a shock and a surprise, and you would have caught the error, because we revealed a time lapse of 12 years of direct exoplanet observation made by the Keck Observatory. So we've had direct images of exoplanets for a long time. Needless to say, I guess it was worth it for Google to take the video down to correct the error, edit it out. I think you can see the video now without that portion. And simultaneously, as a coincidence, their stock went down by 7% and they lost $100 billion. but it's a coincidence, I'm sure. A kilonova is coming. Kilonova are the collisions between neutron stars, and they had always been theorized, but back in 2017, astronomers detected the first gravitational waves from a kilonova event. And fortunately, they also saw the electromagnetic radiation, the visible blast of these two neutron stars colliding into each other. And when they looked at the debris, they detected enormous amounts of gold and other heavy elements that had been formed in just a moment as these two neutron stars collided with each other. We know these things have happened in the past. A kilonova probably seeded the solar system with heavier elements, happened a few 100 million years before the Earth formed. And maybe it's one of the reasons why we have a lot of heavier elements here on our planet than other star systems out there. And now astronomers have found a kilonova in the making. So it's not a kilonova yet, but it will in the future. And what they're looking at is a neutron star that is in a binary system with another massive star. And the two stars are orbiting around each other. One has already gone supernova, and now the second massive star is going to go supernova probably in the next million years or so. And it needs to go supernova in a very special way, which is called an ultra-stripped supernova. And this is where, through the interactions between the massive star and its white dwarf counterpart, a lot of the material gets stripped away and blasted off into space as the star goes through its death throes. And then it still has a lot of mass left over. It collapses, blasts as a supernova, and forms a neutron star, or maybe a black hole if it's massive enough, as its final remnant. And then these two neutron stars will spin faster and faster, orbiting around each other until they collide, and we get this kilonova event. It's only about 11,000 light years away, which is a long way, but fairly small in galactic terms, and not tens of millions of light years away like the other kilonova event. And so if it went off, it would be very bright and very detectable, and then would create afterglows in various wavelengths, powerful gravitational waves that we would detect. It would be a pretty momentous occasion. Now, it's believed that at any point there are 1 to 2 of these kilonova in preparation somewhere in a galaxy as big as the Milky Way. And so it was quite rare and lucky to find one that is in the making like this. Now we just have to be patient for it to explode. But don't worry, it's too far away to cause any damage to Earth, unless the beam points at us. Anyway, don't worry about it. Now, if you enjoy Space Bites, you probably want to subscribe to my weekly email newsletter. I mention this every week, but I'm sure you skip the end of the video, which is fine. I don't blame you. I would do the same. This is an email newsletter that I send out to 60,000 people every week. And I write the entire thing. It is like 5,000 words. The thing is enormous, has dozens of stories, really cool pictures. I provide like enough information so you can decide if you want to go into it. And when I created this newsletter, my goal was like, if you were a person who was interested in space news and you wanted like one comprehensive document that would keep you appraised of all the space news, and you could only choose one, this would be the one. And obviously lots of people agree, are subscribed to it, and you should too. The newsletter is completely free. There's no advertisements in it, and you can go sign up at universetoday.com/newsletter. A black hole was seen just 800 million years after the Big Bang. One of the interesting things that astronomers are realizing with more powerful space telescopes is that the universe is looking surprisingly mature the earlier that they look. Not like we've got the Big Bang all wrong, but just that the large-scale structures of the universe came together a lot more quickly. And we saw what seemed like fairly mature features in the universe, like supermassive black holes, quasars, spiral galaxies coming together earlier than anyone thought. Astronomers were working with the E-Rosetta instrument, which is on board the Russian Spectre satellite. And that instrument was actually shut down because of the Russian war, but there's still a lot of data left over from when E-Rosetta was making its observations. They found a quasar, an actively feeding supermassive black hole, at a time when the universe was only 800 million years old. And this supermassive black hole had already reached 250 million times the mass of the sun. Now, The one at the center of the Milky Way is only 4 million times the mass of the sun. So like this one's even more massive than the one that's in Andromeda. Now there are ones that are billions of times the mass of the sun, so it's not that big. But one of the big surprises is like, how do you get a quasar that is this big this early? Because astronomers see some kind of link between the size and mass of the galaxy and the mass of the supermassive black hole that's at the heart of it. And by making this kind of observation, astronomers will be able to put constraints on the different theories about the early evolution of the universe. Did these supermassive black holes form right out of the initial universe just through matter fluctuations of density? Or did giant stars, we talked about these population 3 stars, did they collapse down and form enormous seeds that are tens of thousands of times the mass of the sun, and those accreted into supermassive black holes? Or was it just small stars combining with each other, finding each other, and then more massive black holes coming together and more massive until finally you get these enormous monsters early on in the universe? These are the different lines of inquiry that astronomers are trying to use to help explain how supermassive black holes got so big so early. What series of evolutionary steps did they take to come together to give us the universe that we see today? And speaking of these large-scale structures of the universe, astronomers have built a map of the large-scale structure of all of the matter and dark matter in the universe. They used 3 different telescopes to make this survey. One is called the Dark Energy Survey Telescope, and it is just scanning night after night the entire universe, as much of it as it can get. They're also using the South Pole Telescope, which is building its own map of the universe, and then they mapped this to images from ESA's Planck Observatory, which was observing the cosmic microwave background radiation. And by having these 3 different data sets, they were able to cross-check one another to make sure that the structures that they're looking at are actually there. And the technique they're using is gravitational lensing. So they're looking for the distortions of light that is happening when it passes large gravitational fields like galaxy clusters. And so they're able to map out all of these different distortions and be able to figure out how much of this is coming from matter and dark matter, and be able to map this out at the large scale across the universe. And what they're looking for is how much does the matter today and in the past clump up against the various theories and simulations that they've done. Now, the results they found largely matched the models, but there were a few discrepancies. They found that there were less fluctuations in the clumpiness than they had expected and the simulations would predict. And so then they can take these observations, feed them back into their simulations, and use that to get a much more precise understanding of the nature of the universe. And when you think about these other concepts that are happening, the crisis in cosmology, different measurements of the Hubble constant at different times, the possibility that there's early dark energy, late dark energy. And so this really powerful, very precise map can then be put to compare against different theories for the formation of the universe and help astronomers reject certain theories and provide more strength to other theories. So over time, we'll learn more and more about the large-scale structure of the universe, and that'll help us learn more about really how the universe's history unfolded over almost 14 billion years. Sierra Space just exploded another habitat on purpose. Sierra Space is building an inflatable habitat that will eventually fly to space. It's called the Large Integrated Flexible Environment, or LIFE. And they've done a couple of tests before where they pressurize the habitat until it pops. And the videos are awesome. You can just see this thing just explode. And now they completed their 3rd test. And this is a test that space agencies like NASA have done for decades, where they slowly pump atmosphere into their module until it catastrophically fails. And NASA was hoping that the test would go for 100 hours. They actually were able to keep this up for 150 hours until finally the habitat exploded. This is just a 1/3 scale of the habitat. And so with these 3 tests under their belt, they're going to scale things up and start testing with a full scale version of this, with different versions of this test again. If they pass all those tests, then they'll be able to start flying this thing to space. NASA had originally wanted this station to be able to handle about 15 years. And based on the tests they've done so far, it looks like they're going to be able to last about 60 years in space into the harsh conditions, vacuum, radiation, cold temperatures, hot temperatures, which is pretty cool. These inflatable habitats are a pretty great idea because they provide a lot of internal living space for a fairly small mass and launch payload size. Just the full-scale life habitat will provide about 1/3 of the internal volume of the International Space Station. When you think about all of the different modules that were launched, docked together to build the International Space Station, imagine just a single launch. Like 3 of these would match the internal volume of the International Space Station. So I can really see the future of space habitats being inflatable modules like this. Imagine them on the moon or Mars. This is probably the future. All right, those were all the news stories that we had today. Now we've got links to every story that I talk about down in the show notes below so that you can just dig in and follow the rabbit hole as deep as you want. You can get even more space news in my weekly email newsletter. I send it out every Friday to more than 60,000 people. I write every word, there are no ads, and it's absolutely free. Subscribe at universetoday.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verabioff, Josh Schultz, and Andrew Gross who support us at the Master of the Universe level. All your support means the universe to us. All right, that was all the news that we had today. We'll see you next week.